So John and Sarah play 2 games of snooker. We've got the probability that John wins the first one and the probability he wins the second one. And these are independent of each other. They cannot draw a game, so it's just a win or a loss. But we need to draw a tree diagram to represent this and then go on to calculate the probability that they win 1 game each. So when we're doing that, we're going to look for the probability of John winning the first, Sarah winning the second, and we're going to add to that the probability of Sarah winning the first and John winning the second. So starting with our tree, I find it easier when drawing this to kind of work backwards to get the branches going into the right places. Okay, so let's add some probabilities. The first game was a probability of 0.4 for John to win. These are exhaustive events, so they add to 1, so that's 0.6. Second game was a probability of 0.3, so for Sarah, it's going to be 0.7. So the probability of John winning the first, Sarah winning the second, is those multiplied. Probability of Sarah winning the first, John the second. And then we need to add those 2 together. So probability of 0.46, and it's said here to write it as a decimal, which we've done. Here we have a fair coin thrown, so equally likely to be heads or tails. And in the game we've got here, A wins, getting a point every time there's a head. B wins with a point every time there's a tail. And we want to find out the probability that player B scores exactly 2 points. So we need to get 2 heads out of the 3. So the probabilities are, it could be a tail, then a head. Tail, head, tail, or head, tail, tail. They're the 3 ways he could get those 2 points. Now there's different ways we could approach this. You may have jumped in and drawn this with a probability tree, which works great, but does take a lot of effort. So I've jumped ahead here and drawn the probability tree for those 3 flips of the coin and worked out the 3 different probabilities here. So this way absolutely works well, and we get our 3 probabilities, which we add together to get the probability of B getting 2 points, 2 tails. So that works out great, but because it's a fair coin, because the probability is even, there are some better ways we could have done it than using the probability tree. We might have seen, for example, just from here, well, if each of these is a half, we can calculate this without needing to draw a whole tree, because the trees are really useful to help us organise our thoughts, especially with trickier probabilities. But on this one, it's fairly straightforward. Alternatively, you might have thought, well, on the first flip, there's 2 possible outcomes, heads or tails. On the second, each of those has got 2 outcomes, so 4 so far. On the third one, again, each of those have got 2, so there's 8 possible outcomes, which are all, in this case, equally likely. And we're looking for 3 out of those 8. So any of these ways will work fine for this question. This is the last question from the task, and we're told there's just red, blue, or purple counters in a bag. We're given the ratio of the number of red to blue counters. We're told someone takes at random a counter from the bag, and key here is that the probability that it's purple is 0.2. And we're going to go on and work out the probability that Sam takes a red counter from the bag. So the probability of purple is 0.2. That means the probability of it being red or blue has got to be 1 take away 0.2, so it's 0.8. We can now share this in the ratio 3 to 17. So adding up those parts of the ratio, then we can divide 0.8 by 20, which gives us 0.04. Now we're interested here in red counters. So the red counters had a share of 3. So we need to do 3 times 0.04. And that's the probability of it being a red counter. And that's the answer we need. We don't also need to work out the probability of it being blue.